All right, guys, so back by popular demand is a video for section 4.3. So if you scroll through, you're going to notice that it's not very heavy on vocab, and we're going to really focus on the application portions of this vocab, all right, so that tomorrow we can kind of go into more rigorous application. So our first term is congruent triangles, and this is going to follow us into our next three sections. So just starting with the definition of congruent triangles, remember you can pause and you can repeat if it's not enough time to write them down, okay? But this idea of congruent triangles says that two triangles are congruent if and only if their corresponding parts are congruent. Now, let me clarify what I mean by corresponding parts. Corresponding parts are talking about the sides and the angles of these triangles, okay? So two triangles are congruent if and only if their sides and angles are congruent. Now, our next term, CPCTC, is a mnemonic device, all right? And we're going to use this quite a bit in our proofs within this chapter. But what that stands for is that corresponding parts of congruent triangles are congruent, which means that if you prove that two triangles are congruent, then you can say that the corresponding parts or the sides and angles of those two triangles are congruent. So let's break that down. So our first example here, it says name all corresponding parts of the following congruent triangles, then write the congruency statement. So the key to this is notation. So what I'm going to do is I'm going to just make a little label. I'm going to talk about the sides, and I'm going to talk about the angles. And we're just going to list, all right, what's congruent in which triangle. So for example, if I take a look at this triangle ABC, and I am going to start with my sides, okay? And I'm going to highlight AB. I'm going to come over to this other triangle and find that same notation, which means that I know that AB is congruent to ED. Okay? Now, next side I'm going to go to, doesn't matter which order you write them. All right, I'm going to go to AC. I look for the two tick marks. All right, I know that AC is congruent to DF. And then our last side is BC. All right, we have those three tick marks. All right, match it up with the three tick marks on the next triangle, and I know BC is congruent to EF, okay? So all three sets of sides are congruent. Now, if we take a look at the angles, all right, same idea. We're going to go off of the tick marks, all right? So I'm going to look at, it doesn't matter which one to start with. I'm going to start with B because it has the one tick mark, all right? So angle B has that one swoop versus angle E also has the one swoop. So I know that angle B is congruent to angle E. Next one, I look for angle D, all right? Angle A, those two have the two swoops. So I know that angle A is congruent to angle D. Okay? And then the last one I have, all right, I have C with the three swoops, F with the three swoops. So I know that angle C is congruent to angle F. Okay? Now, our next part of this is to write a congruency statement. So what we're going to do is we're going to try to establish, all right, through a congruency statement, all right, how are all of these corresponding parts matching up, all right? And this is all about the swoops of the angles, all right, when you're given that information. So, for example, if I take a look at triangle ABC, and it doesn't matter how you write it, okay, for the first triangle, but what matters isn't within the second triangle how you match it up. So if you use these angles right here that you've already established are congruent, I have to make sure I match up, all right, the congruent angles. So I started with A, I have to match up D, all right? Then I went to B, that matches up with E, and then C matches up with F, okay? And you can double check to make sure that you wrote it correctly. So for example, we wrote that AB, side AB, is congruent to ED, all right? They are matched up here. And same with BC is congruent to EF, all right? They match up nicely within our congruency statement. So our congruency statement matches up the corresponding parts, okay? Now, that's nice because we were given the figure. In example 2, we're not given the figure, and all we're given is a congruency statement, but we can still make sure, all right, what's corresponding in which triangle. And it's all about the order of things. So this is our congruency statement right here. It says that triangle BRJ is congruent to triangle CLH, all right? So if you look at the first one, it says is triangle RJB congruent to triangle LHC? So if you match up each of those corresponding angles, all right, they just have to make sure that they're matching up the same. So yes, these two are congruent, all right? R matches up with L, J matches up with H, and B matches up with C, okay? Now, the next one is talking about the sides, all right? So is side RJ congruent to side LH? Yeah, because they match up with one another in the same locations within those congruency statements. So yes, that's true. Letter C then, all right, says, is angle R congruent to angle H? Well, no, because they are not matching up within the congruency statement. So no, they are not congruent. And the last one, is angle B congruent to angle C? Your answer here is yes. All right, they're in the same location. They're both first within those triangle names, okay? Now, our next vocab term is the third angles theorem, all right? And once again, I have that written out, so make sure you take your time. And it says that if two triangles, oh man, I need to change that, all right? If two angles in one triangle are congruent to two angles in a second triangle, then the third angles are congruent, all right? So if two angles in one triangle are congruent to two angles in a second triangle, then the third angles are congruent, okay? So let's go ahead and just draw a picture of this, all right? So let's say I have these two triangles. All right, now I don't know that they're congruent, all right? That's not dependent on here. All right, all we're talking about the angles themselves. So let's say this is triangle ABC, and this is triangle DEF. What the third angle theorem says is if you know that angle A and angle D are congruent, and angle B and angle E are congruent, this is your given information. Your conclusion using the third angle theorem is that angle C is congruent to angle F, okay? Now, that should make sense to us. Let me just throw in some numbers here, all right? Let's say that angle A is 30 degrees, and because I know A and D are congruent, angle D also has to be 30, okay? And let's say angle B is 50 degrees, and it's not going to be drawn to scale, all right? And angle E also has to be 50 degrees. Now, if I would use the triangle angle sum theorem, which says that the angles within a triangle have to add up to 180, that leaves me with angle C having to be 100 degrees and angle F 100 degrees. Once again, not drawn to scale. But the conclusion here that we have, all right, is correct because it says that angle C has to be congruent to angle F, okay? Now, we have a proof left, okay?